Students, welcome to the next lecture, which is lecture number 8. Here, I would like to explain you the topic classification of signals. Move on to the next slide. There are few classifications are there for signals, like first one, deterministic and non-deterministic signal. Non-deterministic is also called as random signal. Periodic and non-periodic signal, even also called as symmetric and odd signals or non-symmetric signals. Energy and power signals, causal and non-causal signals. Let us move to the first classification, which is deterministic and non-deterministic signals. Deterministic means there will be a particular mathematical expression is there for the signal. To draw the signal, we need to follow some mathematical equation. For example, x of t is equal to a sin t is a mathematical representation and its corresponding signal. The behavior of the signal is predictable with respect to time. At each and every time, the signal has some behavior, which is called as deterministic signal, which is determined over the equation. Non-deterministic or random signal. The name itself is saying you random, which is random in nature. We cannot predict the behavior of the signal with respect to the time. With respect to time, we cannot decide the signal's behavior. And it does not follow any mathematical equation. The signal cannot be expressed with any mathematical equation, like a random signal. For example, a noise signal. Noise signal can be given as example for the non-deterministic or random signals. Move on to the next slide. And next classification is periodic and non-periodic signals. Periodic signal means which has some definite pattern for the signal, and the signal repeats again and again over a certain period of time. Signal. Here, observe the signal, and the signal is repeated. The same shape of the signal is repeating. For example, here at 0, the signal is having some shape, and the same shape with the same width is repeated after some time. And after some time, the signal is repeated, which is called as periodic signal. The repetition is also with some format, with some time limit. Exactly at that time only the signal will repeat. That time limit is called time period. That time limit is called time period. So the mathematical expression is x of t plus t is equal to x of t. If it satisfies the equation, such signal is called periodic signal. Here, if it does not follow this equation, such signal is called non-periodic signal or aperiodic signal. Here capital T is called fundamental time period and T is equal to 1 by f. 1 by f means frequency, normal natural frequency, and 2 pi by omega. Omega is the angular frequency. F is the fundamental frequency and units are H, and omega is the angular frequency, units are in the radians per second. Example here, I have taken one signal which is in this shape and it is repeated after every t. It is repeated after every t seconds. From that we can find the time period, which is 2t minus t. The exact shape repeats 2t minus t and t minus 0. 0 of minus t. For that, the time period is capital T. On to the next slide. Example. Checking the periodicity of A cos omega t. Whether this cos signal is periodic or not. I told you in the last slide, it has to follow the equation. It has to satisfy the condition x of t plus t is equal to x of t, right? So I am giving you the original signal x of t, replace t by t plus t. At the place of t, replace t plus t. A cos omega naught t plus t. So omega naught t plus omega naught t, as you know, omega naught formula. Omega naught here what? 2 pi by t. Then t and t gets cancelled. We will get a cos of 2 pi plus omega naught. You know from the trigonometry, cos of 2 pi plus theta is the cos theta only. 2 pi plus something means same. A cos of omega naught. You got x of t plus t is equal to x of t. It satisfies the condition. So you are given you are given x of the original signal cos signal is a periodic signal. Let us check for the sinusoidal signal also. In the same procedure, x of t is equal to a sin omega naught t. Instead of t, what I said to submit? At the place of t, t plus t. And at the place of omega naught formula 2 pi by t. And t gets cancelled. A of sin 2 pi plus omega naught t. This is the original signal again, which is x of t. Again, sinusoidal signal is also a periodic signal. Let us check another signal which is complex exponential signal. That is, x of t is equal to a j omega naught is a complex signal. Already you know. In the previous videos, in the types of signals, I told you about complex exponential signal. X of t plus t is equal to a j omega naught. At the place of t, I told you to submit t plus t. And again, at the place of omega naught, substitute 2 pi by t. And t gets cancelled. A j omega naught of 2 pi. Again, 2 pi e power j theta means cos theta plus j sin theta. Cos of 2 pi plus theta means cos theta only. Sin of 2 pi plus theta, sin theta only. Finally, you get the same original signals. Remember, all the cos signals, sine signals, and complex exponential signal will come under periodic signals. On the next slide, let us solve some problems on this periodicity. If the signal is periodic, find out its time period. This is a problem. You may get for the 2 marks question. 2 marks question. That's why concentrate. Simple. First problem. X of t is equal to j into e power j find. All the problems will be based on the 3 signals only. One is sine, cos, and complex exponentials. First one comes under complex exponential. That is why compare with the standard equation, complex exponential standard, compare with a into e power j omega t. Here a is the amplitude, and simply compare. At the place of j is a. At the place of t is a. But at the place of omega, what is the value? 5. Because here I want only the angular frequency omega 5 radians per second. Now, you know the formula omega is equal to 2 pi by t, that is equal to 5. From this, find out the time period. Here I am checking the periodicity by observing the question itself. I can confirm this is a periodicity because it is a complex exponential signal. All the complex exponential signal will be periodic. Once you confirm it is periodic, then find out its time period is a question. Now t is a time period 2 pi by 5. The units of time period seconds. On to the second problem, which is sinusoidal signal. We know that all the sinusoidal signals are periodic in nature. If periodic, then find out the time period. Compare with a sin omega, the standard sinusoidal signal. Standard sinusoidal signal representation. Then omega is equal to 50 by omega formula. Next problem, cos signal is having both angular frequency and some phase it is having, but irrespective of phase, you don't bother about the phase. We have to concentrate only on the omega, because from this only we need to find out the time period. Irrespective of phase, all the cos signals are periodic in nature. Periodic means it has to repeat again and again. That's all. With some standard shift. From this omega value 10 pi. Omega formula 2 pi by t 10 pi. So t is equal to 1 by 3. This is a time. Next problem. Interesting. Here, the last three problems have given you the standard signals. One is complex exponential signal, one is sinusoidal signal, and the other one is the cos signal. With some phase I have added, but I told you that don't bother about the phase. Forget about the phase. Now, I have given the two signals in the multiplication manner. Two different signals I am giving you here. One is sinusoidal signal and another one is unit step signal, and both are multiplied, and I am asking you whether it is periodic signal or not. The given x of the signal is periodic or not, I am asking. Now, individually check both the signals whether they are periodic or not. First we'll check the sin 10 pi t. All the sinusoidal signals are periodic, so confirm periodic. Now, unit step signal. Unit step signal is not periodic because all the periodic signal will exist from over the range minus infinity to infinity. But your unit step signal, how it is? It starts from 0 and it will end up to 0 to infinity, not a repeated shape. To the negative side, the value is 0. That is why your unit step signal is non-periodic. A periodic and non-periodic signal is in the multiplication will result as non-periodic signal. Periodic signal multiplied by non-periodic signal gives non-periodic signal. Remember this. A periodic signal multiplied by any non-periodic signal will result as non-periodic signal only. On to the next problem, e power minus mod t, which is exponential signal. T can take positive values, then that time it will be exponentially decreasing. If t takes positive value, the signal will be e power minus t. This is a signal exponentially decreasing. If t takes negative value, then the signal will be e power t. E power t means exponentially increasing signal. Then this is not a particular shape and it is not repeating also. So that is the shape should be same. The signal shape should be same throughout the entire. But it is not the same. Negative side is one kind of shape and the positive side is one kind of shape. That is why the given signal is non-periodic. Move on to the next slide. So far I have given one signal and multiplication of signals. Now I want to give you mixture of signals, combination of 2 or 3 signals. At that time we need to find periodicity. First of all, whether that signal is periodic or not. If periodic, find out the time periodicity. Now, if the signal is mixture of 2 periodic signals, addition of 2 periodic signals. One signal is having time period t1 and another signal is having the time period t2. In that case, the signal will be periodic. Mixture of signals, not in the multiplication, addition of 2 periodic signals will be periodic. Then find out the time period. That is, the time period is possible only when t1 by t2. Time period of first signal by time period of second signal is rational. Rational means integer. The time period of the first signal should be some integer. Integer means 1, 2, 3, 9. And the time period of the second signal also must be an integer. 1, 2, 3, 4. Not like then the overall time period of the original signal t will be LCM of t1, find out the LCM. Already you know from your earlier childhood classes how to find LCM. The same thing, LCM of t1, t2. Here I am giving you find out 5 by 2 is a rational number. 7 by 9 is a rational number because 5 is the integer, 2 is the integer. 7 is the integer, 9 is the integer. That is why 8 by 6 is a rational number. Below 5 by 2 pi. 5 is the integer but 2 pi is not an integer. Not an integer because fractional number 2 pi value 3.14. 2 into 3.14, 6.14 is a rational. Sorry, 6.14 is a fractional number. And root 7 is not an integer. That is why these three are non-rational numbers. The condition is T1 by T2 should be a rational number. That means T1 must be an integer and T2 must be an integer. Then the signal is periodic signal and we can find the time period like this. T is equal to LCM of T1, T2. Let us check with one problem. Here I am giving you two cos signals and a mixture of it. First of all, we need to check whether it is a periodic signal or not. We can check the periodicity by this rational concept. If it is rational, the given signal is periodic. If not, non-periodic. Compare with the standard equation cos omega naught 1t plus cos omega naught 2t. Omega naught 1 same as the previous problem, 2 pi by t1, 2 pi by 3. Here pi and pi gets cancelled and find out the t1 3. Now same for the second cos signal omega naught 2, it is 2 pi by 7, t2 is equal to 7. Now the thing is whether it is the rational or not rational. We need to check t1 by t2, integer by integer. 3 is the integer, 7 is the integer. So it is a rational number. The given signal is a periodic signal and LCM of 3, 7 is 21. The total time period is 21. On to the next question, second one. X of t is equal to 3 cos 4t plus 2 sin 5t. By seeing, yes, this is a cos signal periodic. This is a sin signal periodic. Periodic plus periodic is periodic. We can't say like this. We cannot decide whether this x of t signal periodic or not. We cannot. Only we can decide until and unless t1 by t2 is a rational number. Compare with cos omega naught 1t plus cos omega naught 1t. Then omega naught 1t 2 pi by t1 is equal to 4. From this t1 is equal to 2 pi by 4. Then again now t1 is not an integer because pi is a fractional number 2.14. t1 is not an integer. t2 is equal to 2 is integer. t1 by t2 we are getting pi by 4. It is not rational number. It is not a rational number because numerator is not an integer. That is why the given signal is a periodic. By seeing the question, yes, first signal is cos periodic. Second signal is sin periodic. Periodic plus periodic. We should not decide like that. We need to follow this procedure until and unless it is rational number. Until and unless t1 by t2 is a rational number. If it is rational only, we can confirm that it has a periodic signal. Then find out the period, time period. Move on to the next problem, third one. Another distinct problem. X of t is equal to sin square t. Now, till now, I know only single sine or cos. Now I am giving another trigonometric function, sin square of t. Even it is also a signal. We need to check whether it is periodic or not. Now use some trigonometric formulas. Sin square t can be written as 1 minus cos 2t by 2. 1 by 2 minus 1 by 2 cos of 2t. Here the cos signal is a. You forget about the constant. This is simply a constant value. Only you concentrate on your signal cos. Then constant value plus cos signal gives you a periodic signal. omega naught is equal to 2, then k is equal to 5 seconds. Move on to the next problem. Here I am giving you two distinct questions, two distinct signals, 2 into u of t plus 2 into sin u t. You need to check. This time I am going with the sketch. 2 into u of t, I have drawn the u of t signal with amplitude 2 and its addition 2 into sin 2t. Then u of t signal exists only for positive t axis and sinusoidal signal exists over the entire range. Then this is the signal because at the positive axis the u of t signal amplitude will be 2 and the sinusoidal signal amplitude will be 2. The next amplitude will be 4. Then it is also not following the same repetition of the signal. The same shape is not following by observing the signal. That's why the signal is not periodic.